Good afternoon. I'm Jason Flowers, the Program Director of the Oregon Wheat Growers League, and I'm pleased to welcome our members to this Oregon Wheat Talk featuring a disease update with Oregon State University. This Wheat Talk series, hosted by the League, is designed to give our members access to dialogue with OSU staff knowledgeable about diseases affecting wheat. First, we got a few housekeeping items. This meeting will be recorded and posted to the League website for member access and future viewing. For those of you that are experienced with these web platforms, you'll recognize how important it is to avoid background distractions. We ask that you mute your device when not talking so all participants can hear the information clearly. This forum will be in a dialogue format, so we encourage your questions throughout the conversation. Raise your hand or use the chat feature to do so. Today, we will hear from Dr. Christina Hagerty. Dr. Hagerty is an associate professor in OSU's Cereal Pathology Department based out of the Pendleton Station. She'll provide an update on rust and possibly the soil-borne wheat mosaic virus and answer any questions you may have. With that, Christina, I give you the floor.
Great. Jason, thank you so much for the introduction. And I will go ahead and share my slides here. Okie dokie. And just to double check, Jason, does everything look all right? And can you hear me okay?
Yep, everything is good.
Awesome. Well, first of all, thank you so much for having me. The program is very supported by the Oregon Wheat Commission with funding, and we've been the beneficiary of league resources and lobbying efforts. And I will share with you that the best part of my job is the opportunity to interact with growers and stakeholders. So that's why I love what I do. So thanks so much for joining me and having me for just a brief discussion about diseases. You can find me on Twitter at this handle, but always feel free to call me and email me. I just love coming out and doing farm visits. If you're curious about potential disease in your field, or you just want to talk about options for management, happy to discuss. So yeah, I thought today I'd do a quick program overview. We'll talk about stripe rust, and then I will wrap up and discuss some mental health resources that I think are really important. And I think we're really lucky that we are living in an era where we can talk about mental health. So in terms of a program overview, as Jason mentioned, I'm located at the Columbia Basin Ag Research Center in Pendleton. We're co-located with the USDA ARS. I'm adjunct up at Washington State University Pullman campus. That's been a really great experience for me. They are a lot closer than the Corvallis campus and are centered also in the heart of this $2 billion-ish wheat industry in the Pacific Northwest. And then I'm incoming chair for the National Wheat Improvement Committee, where we do lobbying efforts and go back to DC and talk about the importance of research dollars to our congressmen and women. I need to introduce my lab very briefly because everything we do is a team effort. Nothing I discussed today could be done without the help of these amazing people that I get to work with. So Grayson Namdar is my faculty research assistant. He's my right-hand man in the field. His family farm is up in the Helix area, so I also get to leverage his family farming expertise. So I'm very lucky to have him. Rachel Plunkett is a master's student. She's working on a cover cropping experiment. Dr. Gena Mahato is new to the program. He comes to us with a fresh PhD from South Dakota State University, and he's got a lot of agronomic experience. So I've learned so much from him since he started with us in January. And then, of course, Dr. Nguyen Wen, my research associate up in Pullman, she runs the molecular portion of our lab. So thanks so much to these kind people. And if you've seen any of my presentations before, I always talk about this. In the program, we do grower-driven research. And whenever we take on a new project, we just ask ourselves, how does this project or potential research solve pathogen-related profitability issues on the family farm? So I would say, greater than 95% of the stakeholders that we serve are family-owned and operated entities. So we're gonna start real simple, and I gotta show the disease triangle, because anytime we're talking about plant disease, it starts with this disease triangle. So we need three key things to happen to see a plant disease. We have to have a susceptible host, a virulent or aggressive pathogen, and a suitable environment. But just last month, actually, a really beautiful piece of research came out. And I can send the paper to Jason or any of you if you're interested in reading it, where their proposal is actually to make it a plant disease. I believe the shape is a tetrahedron. Anyways, bear with me, a three-legged triangle. But their proposal is to actually add a fourth leg to this and have microbiota, or the plant microbiome, involved in this process. So they're suggesting that in addition to a susceptible host, a virulent pathogen, and a conducive environment, we also need to factor in the microbiome of the plant. And we're realizing as the research progresses that the plant microbiome has a really big impact on how much disease we see. And some work with Oregon State University that I'm lucky to be a collaborator on, which is led by Chris Munt, we're understanding this concept of microbiome mediated disease resistance. So that's a huge handful, or a huge mouthful. But the concept is to essentially think about the microbiome present in the plant or present in the soil, and how that could fight off disease, or potentially how it can make a plant more susceptible to disease. So with that, I thought we'd just look at a bunch of pictures. So essentially, stripe rust, it gets its name from the rust-colored uridinospores that we see. So, or uridospores, you can say either way. But they're these orange blisters that break through the epidermis of the plant. And these orange uridospores, that's our agent of disease. And when you're walking a good stripe rust nursery, your genes are going to be orange when you're done. That's how you know you're going to get great data. And because of drought conditions, we haven't really had a bad stripe rust year for a few seasons now. And while I never hope for stripe rust, one of the opportunities that we get with a big stripe rust year or a good stripe rust infection is we're able to really understand how the new cultivars are performing in real time. Most cultivars are evaluated in a lab basis, so we have an understanding genetically of how that plant is going to perform. But I am of the opinion that we really don't know until things are in the field. So we're able to really look at how things perform in the field, how they interact with fungicides, so on and so forth. So now I have a question for you all. And I told Jason I'm never above answering my own questions. But I want to know, what does stripe rust have in common with the great wheat crop?
A lot of moisture.
Yes, a lot of moisture. So that's the answer. Great job, Jason. You get a gold star for that. So basically, we have two biological systems, stripe rust and winter wheat. And these biological systems are really reliant on many of the same conditions to really proliferate. So if we think about a cool, wet spring with a lot of moisture, think about the past couple weeks we've had in the Pacific Northwest. When we root for the wheat crop and we root for conditions and we do our rain dance, most likely that's going to bring stripe rust along with it because we have this Venn diagram of conditions that overlap and feed both things. So if we look at, this is a relatively young stripe rust lesion. And given this was taken, gosh, probably about 3 weeks ago at the onset of disease expression in our nursery here at Seabark. And so if we look at this leaf, you can see this very subtle margin of, we have a healthy leaf, nice and dark green. We have a bit of a margin here where we see it's starting to get chlorotic. And then we have this epidermis just busted open with those uridospores coming out. And given the right temperature and conditions, this leaf would be completely erupted with those stripe rust blisters in a matter of hours if it had the right humidity and the right conditions. And so with that, I thought we could just very briefly look at the disease cycle of stripe rust. So here we are in springtime, where these stripe rust lesions, they can develop in 2 to 3 weeks. So once we have stripe rust established in a field or in the environment, this disease cycle that happens very quickly is the reason why stripe rust can be very difficult to control. It's because we have multiple cycles that feed each other in the field. And this is a little bit old school, but this is one of my favorite books, Principles of Plant Infections. And Chris Munt, I think, made me read this for my prelim exam. But I like to refer to it because even though it's an old book, some of the principles are just, they hold true. So I'm going to read a very brief sentence. So the uridospores of Puccinia striiformis, so that's the scientific name for stripe rust, are dispersed in clumps. The uridospores being held together by a mucilaginous coating. So there's kind of a gel that holds these spores together. Within these clumps, spores germinate better than when they occur singly. So when we have an infection with multiple uridospores and a lot of spores in the atmosphere, we're more likely to get an infection. And that concept might seem very simple, but these are some of the principles that really guide our management. So anyways, it's important to note that stripe rust is a biotroph. So it needs living tissue to regenerate. With many other plant diseases, we think about, particularly with soil-borne diseases, some of them really tend to infect plants that are weak or already sick from other environmental conditions or poor management. But with stripe rust likes the best of the best, the healthiest wheat. Because of it being a biotroph in nature. And so in terms of it overwintering, there's a lot we could discuss there that I'm happy to come back to, but very briefly, when we have a mild winter, we see stripe rust overwintering in the PNW. If we have a harsher winter, typically the stripe rust infection is going to blow in on weather events and come from Mexico or California. And so with that, I have another question for you all. Why is understanding disease cycles important? Yes, they're boring. I agree with you, but they're important. Why? Okay, I'm going to answer my own question. We have to know our opponent. Do you think Caitlin Clark went into that final game without studying highlight reels for her opponent? She still lost, but of course she studied those highlight reels. Know the opponent, know their strengths, know their weaknesses, know how to understand where you can play the game and really have an input for management. Okay, some more pictures of stripe rust from this morning. So this is our stripe rust nursery where we trial fungicides every year. This year we're running it on some coax wheat. It's a Dagger Soul blend. And we can see where this margin of stripe rust infection is bounded by the veins of the leaf, giving it that name for stripe rust. And so we had rust just show up on Dagger and Soul. But we use a cultivar called PS279 as our spreader rose. And I get this cultivar from Dr. Chen up at WSU Pullman. And it's interesting to note here that you can see some of this tissue is blackening. This is still stripe rust. And this infection occurred on PS279, gosh, about 6 weeks ago. And in just 6 weeks after completing multiple cycles, it has gone into this overwintering cycle where we can see the black teleospores. So another spore type in that disease cycle. These teleospores, the blackening, they produce melanin just like we do when we're out in the sun. And it's a protective mechanism. So that darkening, getting them ready to overwinter, that probably happened because of that cold, wet weather, kind of shocked the system. But within the overwintering structures, we still see very active orange stripe rust lesions. So another picture of the canopy on PS279 with those active blisters, and then down below we can find teleospores. So Jason, stop me if we're out of time. It's already 12:20. I have a couple more points, but I won't go after 12:30. Is that okay?
Well, if we go a little after 12:30, it's not the end of the world. There is
Okay.
one question in the chat though.
Oh, fabulous.
What Aaron wants to know, are you treating any rust at the station?
Yes, we are. So we haven't had it hit our bulk wheat yet, so we're holding back on a fungicide spray, but we have it in our nursery. So right now, we applied treatments at herbicide timing, but then we're gonna continue the trial and apply fungicide treatments at flag leaf. Flag leaf fungicide timing is of critical importance because if we have rust, we want to keep that flag leaf clean. That flag leaf is responsible for a lot of yield potential. And I think of it as our main solar panel that then fuels the plant to then make great grain. And so we want to keep that solar panel clean, just like a regular solar panel. So with genetic resistance, this is just an example. So this is UI Magic CL Plus. This picture was taken, I believe, 2 years ago when we had some rust. And you can see how the field is kind of yellow and orange. That's stripe rust. Now, a cultivar that can be a magic replacement, there are many, would be Appleby CL Plus. This has updated genetics that are resistant to stripe rust. So these field plots are quite large. They're side by side. Appleby is remaining clean, even with stripe rust right next door. And this is due to the work of our amazing breeders in the public and private breeding sector, where the stripe rust disease cycle, we have such a huge population that within that huge population, we can get recombination events and mutations that can overcome the genetics of a new wheat cultivar. So the job of the breeder is never done. Never done. They have to constantly update the locks of the wheat cultivars so that we have this lock and key mechanism with stripe rust. If it's able to unlock the plant genetics and have a disease event, we need the breeders to make those updates and release new genetics to growers. So moving on, hey Alan, glad you joined us. We have some fungicide options. And so this slide is going to seem like it's sponsored by Syngenta. It's not. They just have very easy to recognize fungicide names, and it's their label system is great for examples. And so these fungicide products, they range from cheap as a pesticide application can get to as expensive as a pesticide application can get. And the price has to do with the stacking of these different modes of action. So I thought I would talk a little bit about that. So our group 3 propocanazoles, this is the least expensive. And for that reason, it's very common to put a group 3 in at herbicide timing. This can be a very conservative approach because if we have rust present at herbicide timing, the plants are so small that it's very difficult to recognize and scout it in the field. So if we apply it at herbicide timing, we can reduce the potential for infection as our crop progresses. Then we get into, so that's this year, I think that's running, last time I checked, about $4 product price per acre. But we can get up into the $12 to $15 product price per acre and throw in a group 11. So this would be our strobilurins. And we tend to see the stacking of group 3, group 11. With a group 3 alone, we think of it as having about 20 days of protection from stripe rust. If we add in a group 11, typically we can extend that protection time by about a week. And these 2 modes of action are nice because they work in the plant very differently and they work against the pathogen very differently. So with 2 modes of action, not only do we get active stripe rust, but we get a little bit of prevention in there. Now let's talk about group 7s. So this gets really expensive. So we're talking like $36 product price per acre. If we want to add a group 7, our SDHIs. So that's our succinate dehydrogenase inhibitors. The SDHIs are really important for other diseases, but an SDHI alone does not have great stripe rust activity. And so it's my recommendation to stay away from these more expensive group 7 add-ons, stick with a group 3 and a group 11. And that is because we don't see any better stripe rust control with that very expensive group 7 chemistry. So if we don't see better protection with more expense, and I wouldn't be a fan of having that economic input on your farm. So that's kind of the economic piece. Then the other thing to mention is fungicide resistance. So we're very lucky that given the disease cycle of stripe rust and the organism itself, it's at low risk for developing fungicide resistance. But we have other pathogens in the area that are at high risk or greater risk for developing fungicide resistance, meaning the fungicide won't work anymore. And so for that reason, I think it's important that we save this group 7 chemistry for when we really need it. Things like fusarium head blight, things like eye spot. And potentially diseases that we don't have yet in the PNW, and we hope we don't get in the PNW, but it's nice to keep that tool in the toolbox. Okay, so this is our, we have a 6 manifold fungicide spray cart. This is Duncan, my former technician, geared up, applying fungicides in our stripe rust nursery. And so we trial all kinds of products every year. And this is kind of our opportunity to really work with industry. I think industry and academia or university scientists working together is of critical importance because we all have different resources, and if we bring those resources together, gosh, we can learn a lot. So yeah, we run this nursery every year, and we've done it since 2017. We run it on, this year we're running it on coaxium varieties. Like I mentioned, dagger, it's a dagger sole blend. And if we have coaxium varieties planted this year, it'll be really important to watch them closely because they haven't been through a really big stripe rust epidemic. And okay, so Thad, I missed your chat from a couple minutes ago, but the question is, can weather and heat kill rust that's already growing? So there's a balance there. So that's a great question. There's a balance there that happens with heat units. So that stripe rust needs moisture to continue its cycle, and particularly it needs that morning dew is excellent for stripe rust. So when we get to the point in the season where we basically, you know, you can walk out first thing in the morning and your pants don't get wet, that's when we typically don't have the moisture in the canopy to keep that rust cycle going. And sorry, just for a second, I'm on a call.
Okay, okay.
Sorry about that. And so anyways, when the canopy dries, the stripe rust doesn't have the resources it needs. Then we have the influence of high temperature adult plant resistance, or HTAP. So, and a breeder would probably be much better at answering this question, but in a nutshell, when we get required heat units, multiple days over 70 degrees, we get a suite of genetics that kicks in with the adult plants that can work to shut down the rust cycle. So it works in 2 ways. Okay, so just wrapping up here. So you can access our trial results on plant disease management reports. This is essentially what they look like. We measure area under the disease progress curve. We always measure yield, grain protein, test weight. And then here's an example of different products we chose. We didn't see an effect of any fungicide application in this particular study because this study came from last year where we didn't have stripe rust. So we continue to run the trial even though we don't have disease, as an experiment to see what happens in terms of plant health, if anything. We have some resources for extension for a new generation. Debbie, our office manager, has developed a CBARC YouTube channel where we have videos available. Okay, I think this is my last question. What's the cheapest way to manage stripe rust?
Resistance?
Yes, genetic resistance. Aaron was gonna chime in. Aaron, you get a gold star too.
Okay, good.
Yeah, so genetic resistance is great, not only for economics, but for stress. Managing stripe rust, understanding what product to order, when to apply it, things of that nature, it can be very stressful. So we avoid economic impacts and stress if we plant genetically resistant cultivar. So that's always plan number one. And then as a wrap up, I want to encourage everyone to check out a program called Question, Persuade, Refer. Farming can be very stressful, and this resource helps guide you as to how to help somebody who's having a hard time or is in crisis. And I will share with you that I think this training is really good. And in some of our drought years, I have relied on this training more than I would like to have. So I encourage you to check that out. And then I also want to thank Representative Bobby Levy and Senator Bill Hansel for some new resources that have come to the state of Oregon for a hotline specifically for agricultural folks in the agricultural sector. So with that, I want to thank you for your time and attention and spending a couple minutes with me today. So any questions?
There's no further questions. I want to thank Christina for taking the time today to have this conversation. I think it was really informative for our participants, and we appreciate your time.
You bet. Call me with any questions.
We will do that.